Have you ever gazed through a window and wondered where that pane of glass began its journey? What secrets lie hidden within the grains of sand that, through the alchemy of fire and human ingenuity, are transformed into the transparent barrier between us and the outside world? How does something as simple as beach sand become the high-tech marvels inside our smartphones, the gleaming bottles on a supermarket shelf, or the intricate works of art treasured for centuries? Today we embark on a mesmerizing exploration that starts with the humblest of elements, sand, and follows its transformation into one of humanity's most versatile and essential materials, glass. Let's begin at the root of this story, deep within the Earth's crust, at the vast sand quarries where the journey of glass truly begins. Not all sand is created equal. The best glass starts with pure silica sand, whose grains have been shaped by time and nature, deposited over millennia by rivers and wind, forming vast dunes or beds. These deposits are found in select locations around the world, each with its own unique mineral fingerprint. In places like the shimmering quarries of Eskişehir in Turkey, the landscape is scarred by the steady rhythmic extraction of this precious resource. Here, massive machines scoop up the pale, fine sand, carefully avoiding impurities that might mar the final product. But harvesting the sand is just the beginning. The raw material is transported to state-of-the-art analysis laboratories, a crucial checkpoint on the path from earth to glass. Here, material scientists and mining engineers, wearing lab coats and wielding precision instruments, scrutinize the sand. They examine its chemical composition, searching for the optimal balance of silica, and screen for unwanted minerals like iron, which even in minute quantities can tint the glass an undesired green or brown. Each sample is cataloged, tested, and certified to ensure it meets the strict standards required for the glassmaking process. Quality control doesn't end with analysis. As the sand is washed, sifted, and prepared, it passes through a series of mechanical and chemical treatments. Fine sieves remove larger particles, while powerful magnets pull away trace metals. Only the purest, most consistent grains are permitted to continue on their journey. It is a process that marries the brute force of industrial mining with the delicate precision of modern science, a testament to how far we have come from the primitive methods of our ancestors. But what happens next is nothing short of transformation through fire. A process as ancient as civilization itself, yet refined by centuries of technological advancement. In the heart of a glass factory, towering furnaces roar like captive volcanoes, their interiors glowing with an otherworldly orange light. The purified silica sand, often mixed with soda ash and limestone, is fed into these high-temperature kilns. The temperature inside climbs to a staggering 1,500 degrees Celsius, hot enough to melt rock and sand into a viscous, glowing liquid. This molten glass flows like honey, its surface shimmering with swirls of light and color. Specialized channels guide the molten mass toward forming machines, or in the case of traditional glass blowing, toward the skilled hands of artisans. The transition from solid to liquid is not merely a change in state, it's a rebirth, where the sand is rendered unrecognizable, its particles fusing together to become something entirely new. As the molten glass emerges from the furnace, it is shaped with breathtaking speed and precision. In vast industrial halls, automated machines deftly blow, press, or spin the glowing material into bottles, jars, and panes. Conveyor belts move with clockwork regularity, carrying each piece through a carefully controlled cooling process called annealing. This step is critical. If glass cools too quickly, internal stresses can cause it to crack or shatter. By gradually lowering the temperature, the glass is given time to settle, ensuring its strength and clarity. Yet, alongside these cathedrals of industry, another tradition endures, one that is steeped in artistry and human touch. On the storied island of Murano, just off the coast of Venice, master glassblowers continue a centuries-old craft. Here, the furnace is a crucible for creativity as much as for chemistry. Artisans wield long metal pipes, gathering a blob of molten glass on the end, then gently blowing and shaping it with practiced skill. Each twist and turn of the pipe, each careful breath, coaxes the glowing mass into delicate vases, intricate sculptures, or vibrant chandeliers. The process is mesmerizing, a dance of fire and imagination, where no two pieces are ever quite the same. Contrast this with the immense production lines of facilities like Paşabahçe in Turkey, where millions of drinking glasses and bottles are produced every day. Here, automation and scale are king. Robots and machines handle the molten glass with chilling precision, ensuring every product is identical, economical, and flawless. Factory managers oversee a ballet of efficiency, where human intervention is limited to supervision and maintenance. This dichotomy between the handmade and the mass-produced, the artistic and the industrial, defines the world of glass. It is both a medium for personal expression and a backbone of modern commerce, bridging the worlds of art and industry in a way few other materials can. But glass is not content to rest on tradition. In the 21st century, it has evolved into a cornerstone of the high-tech age. Imagine glass that can change its properties at the flick of a switch, smart glass that tints or clears to control heat and light, revolutionizing architecture and energy efficiency. In laboratories from Japan to Germany, engineers at companies like Asahi Glass and Schott AG are pushing the boundaries of what glass can do. Their innovations are transforming entire industries. Consider fiber optics, those hair-thin strands of glass that carry the world's data at the speed of light. From the depths of the ocean to the heart of your city, these invisible highways form the backbone of the internet, enabling instant communication across continents. The production of fiber optic glass is a marvel of precision, requiring ultra-pure materials and flawless manufacturing. In sterile environments, engineers draw out molten glass into fibers thinner than a human hair, then coat and spool them for transport around the globe. Or take a look at the latest generation of screen glass, used in everything from smartphones to televisions. Gorilla Glass, developed by Corning in the United States, is engineered through chemical strengthening, making it tough enough to survive the drops and impacts of daily life. In clean rooms, technicians inspect sheets of glass under powerful microscopes, searching for the tiniest imperfections that could compromise performance. Laser cutters slice each panel to exact specifications, ready to become the window to your digital world. Glass even reaches into space. Specialized formulations, created for agencies like NASA and the European Space Agency, withstand the extreme conditions of rocket launches and the vacuum of orbit. These are not your everyday window panes, but high-performance materials that help protect equipment and astronauts alike from the harsh realities of outer space. The story doesn't end with today's technology. The future of glass is being written in the laboratories of tomorrow. Imagine implantable, biocompatible glass devices, tiny sensors or scaffolds that heal inside the human body, dissolving harmlessly after their work is done. Or consider the promise of sustainable glass packaging, a response to the world's growing concern about plastic waste. Unlike plastic, glass can be recycled an infinite number of times without losing its purity or quality. Forward-thinking startups and established giants alike are investing in new recycling systems, striving to close the loop and create a truly circular glass economy. Perhaps most exciting are the experimental frontiers, flexible glass that can bend without breaking, potentially revolutionizing everything from wearable electronics to foldable displays, glass batteries that could hold more energy and charge faster than traditional lithium-ion cells, and entirely new types of glass, engineered at the molecular level for applications we've only begun to dream of. Behind all of these advances are teams of researchers, materials scientists, optical physicists, and engineers who push the boundaries of what's possible. In cutting-edge research centers, they experiment with novel compositions, test materials under extreme conditions, and harness the power of simulation and artificial intelligence to design the next generation of glass. As we look back on this journey, from the sun-bleached dunes of silica sand to the gleaming towers of modern cities, from the fiery furnaces of Murano to the sterile labs of the future, one thing becomes clear. Glass is far more than a transparent barrier or a vessel for our drinks. It is a testament to human creativity, a material that has shaped and continues to shape the course of civilization. So next time you look through a window, hold a glass in your hand, or tap on your phone's screen, remember the incredible voyage that piece of glass has taken. From the heart of the earth to the edge of space, from ancient art to cutting-edge science, glass reflects our world and our aspirations. If this journey into the world of glass has sparked your curiosity, imagine what other stories are waiting just beneath the surface of everyday things. Don't miss out on our next deep dive. Make sure to subscribe so you can join us as we uncover the hidden wonders all around us.